students, let us have a brief recapitulation of metals and nonmetals. We have the periodic table of elements in chemistry, which includes 118 elements in total. This periodic table is also known as modern periodic table. Earlier, it was not designed like this. We have elements in this periodic table, and science has come along a long way since Aristotle's theory of air, water, fire, and earth. The elements alone or in combinations make up our bodies, our world, our sun, and in fact, the entire universe. Right? The periodic table have the elements divided into three main categories: metals, nonmetals, and metalloids. You may clearly see here the three differentiation of metals: nonmetals and metalloids. Metals are generally solid at room temperature, like nickel, rubidium, gold, copper. Ni is nickel, Au gold, Cu copper, and Rb rubidium. Metals appear to the left of the dark zigzag line on the periodic table, and most metals are solid at room temperature. You all know. The only exception is mercury, which exists in liquid state. Metals are quite strong. They have luster. That means they are shiny. See, cesium is seen here, a very shiny metal. With atomic number 55 and mass number 132.90. Metals are ductile too. That means they can be drawn into thin wires. And this particular property of metals make them suitable for making jewelry. Metals are malleable too. That means they can be hammered into thin sheets. You must have seen aluminum foil in your kitchen, which is used for packaging food items. That is the best example. Metals have a high melting point, and metals are good conductors of heat and electricity too. That's why they are used for transmission of electricity via wires like copper wires, aluminum wires. You must have seen such wires at your place. A chemical property of metal is its reaction with water and oxygen, and it results in corrosion and rust. We discussed corrosion in detail yesterday. Now coming over to nonmetals like nitrogen with symbol N and atomic number 7. Selenium, Se, atomic number 34. Bromine, Br, with atomic number 35. These nonmetals are quite antagonistic in nature with those of metals. Nonmetals occur to the right of the dark zigzag line on the periodic table. Although hydrogen is in family 1, it is also a nonmetal. Many nonmetals are gases at room temperature, except bromine, which is a liquid at room temperature. Nonmetals do not have luster. That means they are dull. Look here, selenium is given. Quite dull, right? Non-metals actually don't have shine like that of metals. They are brittle too, as they can be broken easily by hitting against something, like phosphorus with atomic number 15 and symbol P. But this brittleness is quite not so good. Non-metals have low density, like you must have seen sulfur powder, a low density substance, and it is a non-metal. Then non-metals also have low melting points. That's why they are also the poor conductors of heat and electricity. They can't be used for conduction of heat and electricity. Other than metals and non-metals, we have metalloids also in our periodic table, which have the properties of both metals and non-metals. Like we have germanium, silicon, polonium, arsenic, etc. Germanium with symbol Ge, polonium Po, silicon Si, and arsenic with symbol As. These show properties of both metals as well as non-metals and can be found clustered around the dark zigzag line that separates metals and non-metals. Silicon chips are used in softwares. Properties of metalloids. They have properties of both metals and non-metals, as you all know, like boron with atomic number 5 is a metalloid. Metalloids are solid and can be both shiny as well as dull. Like antimony with symbol Sb is shiny and silicon is dull, and both are metalloids. We have several other metalloids too, which are used in industrial purposes on a large scale. Metalloids do conduct electricity and heat better than non-metals, but they can't be compared to the metals' efficiency in conduction of heat and electricity. Metalloids are malleable and ductile like silicon. Silicon chips are used in computers and mobiles. Silicon and germanium are also used in solar panels, solar cells,